Exercise 2.2, Question 1, Part 3. Find the zeros of 6x squared minus 3 minus 7x and verify the relationship between the zeros and the coefficients. Step 1. Rearrange into standard form and identify coefficients. The polynomial is given as 6x squared minus 7x minus 3 after rearranging in descending powers of x. Here A equals 6, B equals negative 7, and C equals negative 3. Step 2. Factorize by splitting the middle term. We need two numbers whose sum equals negative 7 and whose product equals a times C, which is 6 times negative 3, equals negative 18. Testing the pair negative 9 and positive 2, negative 9. Plus 2 equals negative 7 and negative 9 times 2 equals negative 18. Both conditions are satisfied. Splitting the middle term, 6x squared minus 7x minus 3 equals 6x squared minus 9x plus 2x minus 3. Grouping, 3x times 2x minus 3 plus 1 times 2x minus 3. Factoring gives 2x minus 3 times 3x plus 1. Step 3. Zeros. Setting each factor to 0, 2x minus 3 equals 0 gives alpha equals 3 over 2, and 3x plus 1 equals 0 gives beta equals negative 1 over 3. Step 4. The parabola crosses the x-axis at 3/2 and negative 1/3. Both crossing points are clearly visible on the graph. Step 5. Verify. Sum, 3/2 plus negative 1/3 equals 9/6 minus 2/6 equals 7/6. Negative b over a equals 7 over 6. Verified. Product, 3/2 times negative 1/3 equals negative 3/6 equals negative 1/2. C over A equals negative 3 over 6 equals negative 1/2. Verified. All relationships are confirmed. Exercise 2.2, Question 1, Part 4. Find the zeros of 4u squared plus 8u. And verify the relationship between the zeros and the coefficients. Step 1. Identify the coefficients. P of u equals 4u squared plus 8u. We note that this polynomial has no constant term, so C equals 0. Here A equals 4, B equals 8, and C equals 0. Step 2. Factorize by taking out the common factor. Both terms share a common factor of 4u. So 4u squared plus 8u equals 4u times the quantity u plus 2. There is no need to split the middle term here since we can factor directly. Step 3. Find the zeros. Setting each factor to 0, 4u equals 0 gives alpha equals 0, and u plus 2 equals 0 gives beta equals negative 2. So the two zeros are 0 and negative 2. Step 4. Observe the graph. The parabola y equals 4u squared plus 8u opens upward and passes through the u-axis at 2 points, at u equals 0, which is the origin, and at u equals negative 2. Both zeros are visible and the vertex of the parabola sits between these 2 points. Step 5. Verify. Sum of zeros, alpha plus beta equals 0 plus negative 2 equals negative 2. Negative b over A equals negative 8 over 4 equals negative 2. Sum is verified. Product of zeros, alpha times beta equals 0 times negative 2 equals 0. C over A equals 0 over 4 equals 0. Product is verified. Both Coefficient relationships are confirmed. Note that when C equals 0, the product of zeros is always 0, which means at least one 0 must be 0 itself. Exercise 2.2, Question 1, Part 5. Find the zeros of t squared minus 15 and verify the relationship between the zeros and the coefficients. Step 1. Identify the coefficients. P of t equals t squared minus 15. Here are equals. 1, b equals 0 because there is no t term, and c equals negative 15. Step 2. Apply the difference of squares identity. We recognize that 15 equals root 15 squared. So t squared minus 15 equals t squared minus root 15 squared. Applying the identity a squared minus b squared equals a minus b times a plus b. T squared minus root 15 squared equals t minus root 15 times t plus root 15. Step 3. Find the zeros. Setting each factor to 0, t minus root 15 equals 0. Gives alpha equals root 15, and t plus root 15 equals 0 gives beta equals negative root 15. The two zeros are root 15 and negative root 15. Step 4. Visualize on the graph. The parabola opens upward with its vertex below the t-axis at the point 0, negative 15. The curve rises and crosses the t-axis at positive root 15 on the right and at negative root 15 on the left. These symmetric crossing points confirm the two zeros. Step 5. Verify. Sum of zeros, alpha plus beta equals root 15 plus negative root 15 equals 0. Negative b over a equals negative 0 over 1 equals 0. Sum is verified. Product of zeros, alpha times beta equals root 15 times negative root 15 equals negative 15. C over a equals negative 15 over 1 equals negative 15. Product is verified. Both relationships are confirmed as expected.